What's up, guys? Today I will be talking about what is Apache Spark and its architecture in a very simple term. So let's get started. What is Apache Spark and its architecture in a simple term? So we will start with a simple example to explain the definition of Apache Spark. So let's say I have a bag of candies and I don't like orange candies. So somebody gave me an instruction. Can I eat all yellow candies in less than 60 seconds and eliminate the orange candies? Of course, the answer would be no. Then we might think of what resources do we need to eat all yellow candies in less than 60 seconds and try to eliminate the orange one. So here comes the concept of Apache Spark. So it is an analytical engine for processing big data, and it follows MVP, massive parallel processing, which means we can perform several tasks parallelly at a time. That's the feature of Apache Spark, and this feature is being embedded in Databricks. So that's the core engine of Databricks, and that's the definition of Apache Spark. So this is the execution of the engine Spark execution engine. So it follows divide and conquer methodology. So if we perform some action, so action would be something like display or count. So let's say in this example, if we perform some action, then the engine divides the action, the jobs, stages, and tasks. This is the process of how the Spark execution works. So it divides the code into jobs, stages, and tasks. So to answer the questions, can we eat all yellow candies in less than 60 seconds and try to eliminate the orange one? So through Apache Spark, yes, it is possible. We can eat all yellow candies in less than 60 seconds, and we can definitely eliminate the orange one. If we have X amount of people, let's say 10 not 10, 50 or 100 people eating candies parallelly at the same time. If 100 people are eating the bag of candies parallelly at the same time, then in less than 60 seconds we can definitely eat all yellow candies. So that's the power of Spark. So it processes data parallelly, and it divides the tasks so that at a time we can process data parallelly. So hope this makes us clear about the definition of Apache Spark. So coming to key concepts in a simple term, so key concept we have included parallelism. What is parallelism? Partitions, job stages and tasks, drivers, executors, clusters and nodes, slots, cores, and threads. So we will discuss this in a very simple term. So, what is driver? So, we can imagine a classroom with a teacher and student. So, teacher acts, we can imagine teacher as our driver. We can say the all the instruction that goes through driver to their students. So, the driver acts as a teacher in a very simple term. So the driver, what he does is he gives instruction regarding who would process the candies. So who would process the candies means who would process the yellow, who would eat the yellow candies in less than 60 seconds and eliminate the orange one. So all the process steps, or the driver acts as a leader on deciding the steps, but it does not touches the process or process the data. It only gives the instruction. That's the feature of driver. So executor is something, is the main application where your code is running. So for example, counting the yellow candies and filtering the orange one. So all the operations operation goes under executor. So executor is the main application where code is running or processing your data. So the difference between driver and executor is driver does not process your data or process your data, whereas executor is a Java virtual machine where we can run or process our data. So so as a overall, if we can see the if the driver and executor comes together, they form a cluster. That's what Spark cluster means. So what is node? So the node and executors are similar. So a node or executor is a JVM, Java Virtual Machine, where our code gets executed or processed. So it's very similar term. You can say node or executor or workers, all are similar. So what is slots, threads, and cores? So slots is a spot on where driver assign their task. So it is the smallest unit which performs the operation. So within a node, we can see we can take an example in a classroom or desk. In a desk, three students can sit in that desk. One student, so we can think that as a core, or so core is something your hardware, and trades is something your trade polling, and your slots is a spot on where driver can assign their task to run the jobs. So the core is the smallest unit, we can say student in our classroom. So for example, in this example, what we can see is six executors. Six executors, it means six desks. So in one desk we see two students sitting. Likewise, we have one, two, three, four, five, six desks, and two students means two core. So six executors or nodes or workers times two, it means like 12 tasks. We can perform 12 tasks parallelly at a time. So so the driver's job is to look at the data set and figure out the number of partitions. Partitions would mean dividing your larger files into smaller chunks. So so on Apache Spark, the engine, the 128 MB chunks of large partition, the partition of a file, this is the default size of partitioning the file. So the driver is jobs is to look at the data set and then figure out the number of partitions and create a task for each partition. So, so initial going back to initial question instruction. So can I eat all yellow candies in less than 60 seconds and try to eliminate the orange candies? So this is the one job. One instruction would mean one job that could involve one staging. So we haven't explored more about staging, but we can discuss that in our later video. So the job is your instruction to complete the task. So if going back to Databricks, what we can see here is we have, so this is the node. The node would mean, if we are using multi-node, which means, let's say this is let's say we are, as said, like node workers are similar. So node would mean something, let's say I have two nodes would mean, we let's say two boxes, and within two nodes, let's say here we see the four cores, would mean like we have four. If we imagine a classroom, we have four students in a classroom, one driver, and then this would be one desk, two desks, within two desks, This would be for students. So this desk would mean, as a whole, would mean node. Node would mean a computation, Java virtual machine. So two node would mean we are using two Java virtual machine to process our data, and within the two Java machine we are using four cores each, So two nodes times four each, four cores, which means that eight tasks we can perform parallelly at a time. Eight tasks we can perform uh, parallelly parallelly at a time. So if we can do a eight partition at a time. So if we have a 125 MB files, 125 MB times 8, we can process this much once parallelly. So that's the core concept. So it has a memory of, so each course has a memory of 30.5 GB to process the data. So yeah, that's the concept. So this is the driver. It comes under, if we go under compute, you can see driver would mean gives the instruction but does not process your data. Your executor, nodes, workers, all are same, and within that we have cores, which is the smallest unit, who performs the task parallelly. So hope this makes sense to you, and let me know if you have any questions or feedback for me. Yeah, and do like my channel, and motivate me to create more videos. Thank you so much. Bye.